Hey everyone, welcome to Rolle's theorem. This is a special case of the mean value theorem, so you really need to know what the mean value theorem is before you look at this. It's not exactly difficult, but it's a good idea if you know that. Okay, so what this tells you is if you have a continuous function on an interval from a to b and it's closed, it's differentiable everywhere on this interval, and if f of a equals f of b, which equals 0, then there's at least one number between a and b such that f prime of c equals 0. So what does this mean? Let's break it down in picture-wise. So what they're saying is, number one, you have a continuous function on a closed interval a to b. And between that interval, you're differentiable, so the derivative exists everywhere. What they're saying is that, and then that they're saying is that f of a and f of b equals 0 and they equal each other, meaning these are the zeros here. Okay, and that's what that means up here. Those are the zeros. So if all that plays out, a continuous differentiable function on an interval a to b, okay, then they're saying that there's going to be this point C where the tangent line is 0, and that's where this comes in. So that's what we're looking for. Okay, so let's look at a condition of Rolle's theorem and see if it works out. So find the value of C such that it satisfies Rolle's theorem for f of x equals x to the fourth minus x on the interval 0 to 1. So let's start. Number one, it's continuous. How do I know it's continuous? Well, it's a polynomial. Polynomials are continuous everywhere. So I've got that. Okay, it's continuous on the whole interval. It is also differentiable on a to b. Okay, it's a polynomial. It's differentiable everywhere. Okay, on 0 to 1. Continuous over 0 to 1, the whole interval. So we have a continuous differentiable function. So now, does f of a equal f of b, and does that equal 0? So that's the third kind of thing I need to check. Well, let's see. A here is 0, b is 1. So let's look. F of x is equal to x to the fourth minus x, so f of 0, hey, guess what? You plug 0 into both of those. For x, you get 0. If you plug 1 in, you also get 1 minus 1, which is 0, so that works out. So now this definition says, hey, this all works out. Then we have this point C where the derivative is equal to 0. So now I got to find my derivative. Okay, so f prime of x is equal to 4x cubed minus 1. The definition tells us that we're looking for where the derivative is 0. That means the horizontal tangent line. So when I solve this cubic for x, I have 1 equals 4x cubed. Okay, I divide each side by 4 and I get 1/4 equals x cubed. So x is equal to the cube root of 1/4. Now you can simplify that a little bit, you could rationalize that, but there's the value of C, and I shouldn't say x, I guess I could go here. If you want to be proper, you could say C, this is all would be a C, right? So we should have C there. Anyway, so that's our example of how to use Rolle's theorem, and which is part of the mean value theorem. So if you have any questions or comments, let me know. We'll see you next time.